Hello everyone. In this video, we are going to discuss about Cramer rule. So, what is the importance of Cramer rule? Why we are using Cramer rule in network analysis? Okay. So, objectives here in the circuits. Why you need to use Cramer's rule to find the voltage or currents depending upon the circuits. Okay, so student is expected to understand the following at the end of the lesson. So use KVL at meshes or loops to formulate circuit equations. Create matrix from the circuit equations first by using KVL at the meshes or loops. You need to formulate the equations. After finding that, so those equations you need to write in matrix form, that is a creation of matrix form. Then by using this Cramer's rule, we have to find that is a solve for unknown mesh currents by using this Cramer's rule. Now we'll see the different examples how we need to apply this Cramer's rule to find the currents for the given circuits. Now, in this example, determine the currents I1 and I2 for the given circuit by using Cramer rule. Now, the circuit you see here. So, it is one of the simple circuit because first we will see the 2 by 2. You can say here two equations, two unknowns. We will see two loops here, right? So, in the circuit, no current directions, nothing, simply voltage source are given and it is a resistance circuit. Now what we will take here, we will take the notations, that is a current directions in this loops. After that we will apply the KVL to write the expressions. That is the first form because already we know when you need to apply KVL. Similar way for this, because these are the two loops, you can apply KVL directly. Okay, instead of going for the KCL. Now that is a first step. We need to first rearrange the circuit with proper labels. That is the label we are taking here. In the first loop, that is the I1 current. In the second loop, it is I2 current. Then you need to apply the first mesh analysis, that is a loop, by applying KVL for the loop 1 and loop mesh analysis. That is only first step we are taking for the mesh 1. We will write the KVL expression of unknown values for the given circuit, apply KVL for the mesh 1. That is wherever you are showing here I1, that is called mesh 1. Wherever you are showing for the I2, that is mesh 2. So in the mesh 1, we apply now KVL. So once you are applying KVL, what you will get? 6 volts, 6 equal to 14 I1 plus 5 plus 5. It is a simple, right? Both are connected in series. So 10 I1 minus I2. Right? So that is a circuit. Now you see here, this is the expression 6 equal to 14 I1 plus 10 into I1 minus I2. After simplifying, 10 equal to 36 equal to 14 plus 10, 24 I1 minus 10 I2. That is the first equation from the mesh 1. Similarly, you have to apply for the KVL for the mesh 2. We will get the another equation, that is here. Same circuit again we repeated here for writing the expression. So that is, we need to apply KVL for the mesh 2. What you will get here? Simple, right? Minus 5 you can take in the direction. Minus 5 plus 10 I2 plus 10 I2 minus I1 equal to 0. You can take that is minus 5 equal to minus 5 because in this direction. If you are taking that, that is opposite direction, right? That's the reason minus 5 is equal to 10i2 plus 10i2 minus i1. So after simplifying, minus 5 equal to minus 10 I1 plus 10 plus 1 20, right? 20 I2. So now we got two equations, equation 1 and 2. So those two equations again we are writing in simple, that is a we got two equations, equation 1 and 2. Now we know already it is a general method solving these two equations. We will get two equations, two unknowns I1, I2 values. That is a general procedure. Sometimes if we may get through three equations, at that time again solving those three equations by using this, it is a little bit time consuming process. So at that time if you are using Cramer rule, it is a very easy to find the unknown values. Okay, now here it is a two equations only, but we are taking Cramer rule because already asked in the problem, that is by using Cramer rule we need to find the current values. Okay, now what we are taking, these two expressions we are writing in matrix form. How it is, you know already matrix, right? So those matrix form, that is the first step, solving by Cramer's rule. So all we need to write in matrix form, 24 minus 10 minus 10 20, that is a matrix, square matrix, into I1 I2 equal to 6 5. You see here. So this is the matrix of those two equations. Okay. Now we need to find I1 I2. How to find, generally if you want here, so this matrix you should shift that side and inverse, find out the inverse, and then multiply with that, you will get that. It is a into x equal to b, x equal to a inverse b. Similar way only here, but we are not going for inverse and all. So by using this Cramer's rule, sorry, Cramer's rule, what you have to take, first you need to find the determinant of the square matrix, and second one, which one you want. Suppose you want to find the I1, you need to find delta 1. So that means in place of this, if you want to find out first one, in place of this, replace these values with this. Okay, so just remove this one and keep these values here and find the determinant, that is the delta 1. Similarly, if you want to go for the I2 value, at that time what you have to take, so remove these values, again keep these values here, find the determinant. So we'll get delta 1 and delta 2. So then after finding those values, we need to find I1 is equal to delta 1 by delta and I2 equal to delta 2 by delta. Okay, this is the procedure we have to find the values of currents I1 and I2 into meshes. Now we'll see finding the determinant here. So that is the first one. It is called determinant delta. So it is a square matrix because number of rows and columns are same. Yeah, 2 by 2 matrix here. Okay. Now how to find out this determinant of this? You know it is a 2 by 2 matrix, very simple. 24 into 20 minus 10 into minus 10. It is a minus into minus plus only. So 24 into 20 minus 100 will get 380. So that is a delta. First part is over. Now we need to find delta 1 and delta 2. Okay. Now you will see next step here we need to find delta 1. Here what you have to take. So we need to replace that value first column with the right hand side. In the previous we have right. So those elements you see here, that is remove 24 minus 10 because we need to find out I1. At that time you have to find delta 1. So replace those blue values, minus 20, 24 minus 10. So 6 minus 5. So again find out the determinant, 6 into 20 minus 10 into 5 because minus and minus plus, right? So 120 minus 50, 70. This is the next one. Similarly, you need to find out delta 2. It is same. Again, here what we have to take? So minus 10, 20, we should replace with the 6 minus 5 value. That we'll see here. That is the next step. Okay, second column we should replace. So then we need to find out the determinant 24 into minus 5 minus minus 10 into 6. Okay, 24 into minus 5 minus 120. So minus of minus plus 60. So that is a value is minus 60. That is a minus delta 2. Now we got both. So delta 1 and delta 2 and also total determinant, that is a delta. Then we need to find out the values of currents I1 and I2. How to find out? By using this Cramer's rule. I1 is equal to delta 1 by delta and I2 equal to delta 2. So just substitute that value. I1 equal to what value got? That is a delta 1 by delta. Delta is 380, delta 1 you got 70, right? So 70 by this. That is the value 0.1842. That is amperes. If it is in milliamperes, 184. Okay, that is a by 1000, right? So that is the first value. Similarly, we need to find out the I2 delta 2 by delta. So delta 2 it is minus 60, okay, by again 380. How much we will get here? So 0.157. So why you are taking this one? That is a I2, that means in this opposite direction. So the current value is not negative direction, it shows that it is in the opposite direction. That is the meaning of that 157.9 milliamperes. In this way, we need to find the current values I1 and I2 for the given circuit with the help of Cramer's rule. Similarly, we'll take another example for the 3 mesh. Okay, now we'll see. You see here, use mesh analysis to determine 3 mesh currents in the circuit below. Use Cramer's rule for simplification. Sometimes they may ask, use this special method, that is a Cramer's method for simplification. Sometimes they may not ask, but depending upon the problem, you as you are convenient, you can use that method and you can find the values. Okay, if they are not mentioning, it's not compulsory. If they are mentioning, compulsory how to use this method. Okay, that is Cramer's rule. Now the circuit ready. Already directions, that is a mesh currents also they mentioned I1, I2 and I3 with the directions, right? So again no need to go for the directions and all already mentioned. Now what we have to take here? We have to take here, apply KVL for all 3 meshes, find the expressions and then write in matrix form. After that find the determinants delta 1, delta 2, delta 3 and delta. So once you are finding all these 4 delta, delta 1, delta 2, delta 3, then by using this directly we can take delta 1 by delta equal to I1, delta 2 by delta is equal to I2 and delta 3 by delta is equal to I3. Okay, same similar to first one. Now we will see the first one. Apply KVL for all the loops directly one by one. I am taking all, right? So all 3 loops. Now you see here, because you know how to find out directly, we can take that. That's the reason I mentioned all the values at a time. So 7 equal to, or we can take minus 7. 7 equal to 1 into I1 minus I2 plus 6 plus 2 into I1 minus I3 equal to, that is already I mentioned 7. Otherwise minus 7 equal to 0. Similarly, second one, what is second one here? So 1 into I2 minus I1 plus 2 into I2 plus 3 into I2 minus I3 equal to 0. No source, right? And the third one, what you will get here? 2 into I3 minus I1 minus 6 plus 3 into I3 minus I2 plus 1 into I3 equal to 0. Okay. Then simplify those three equations. You will get the equation 1 and 2, 1, 2, 3. Okay, so from this here you can see here I1, here also I1. Just simplify that. Here 1, here 2, 3I1 minus I2 minus 2I3 equal to, this is the 6 minus 1 minus 7, right? That is minus value, shift that side, it is equal to plus 1. That is the first equation. Similarly second, here minus I1 plus 2 plus 1, that is a plus 3. So 1 plus 2, 3 plus 3, 6. 6I2 minus 3I3 equal to 0. That is second equation. Similarly third one here, what you will get? So minus 2I1, okay, this is minus 3I2, this is the 2 minus 2I1 minus 3I2 plus here 2 plus 3 5 plus 1 6I3 equal to 0. This one you shift that side, it is plus 6, right? So these three expressions. Now what you have to take? You have to write in matrix form. Okay, that is matrix form, right? So 3 minus 1 in row wise, minus 2 minus 1 6 minus 3 minus 2 minus 3 6. That is a square matrix, 3 by 3 matrix. And currents I1 I2 I3 equal to 106. Okay, now we need to first one, we need to find out the determinant from the square matrix. Okay, this one, by using this we need to find out the square matrix 3 by 3. And then after that, if you want to find out the delta 1 for I1, so you need to replace this with this value. Okay, and then find the determinant. If you want to find out delta 2 for current I2, so replace these values with this and then find out the determinant. Again for I3, these green values, okay, so replace with this, again find the determinant. That's all. Okay, that only we'll see step by step. First find out the graph determinant. You know it is a 3 by 3. We need to take, that is how to find out 3 into 6 into 6 minus minus 3 into minus 3. That is the first one. You can see here 3 into 6 into 6 minus minus 3 into minus 3. That is the first one. Second one, what you will get? Either this way or this way. Anyone you can take, either this way or this way. So if you are taking this one, minus 1, okay, so you need to leave this 2 and you need to take this. That is a minus 1 into 6 minus minus 2 into minus 3. Okay, plus here it is a minus 2, right? Minus 2 into, again these two leave, find out this. That is a minus 1 into minus 3 minus minus 2 into minus 6. So total value is, simplify those values, you will get the delta, that is a 39. We got delta, right? So similar way, just I mentioned here, if you want to find out delta 1 for the current one, current I1, what you have to take here? So this value, okay, so blue color, first if you want to go for the only current one, just to replace this value, this values with the right hand side, already I have shown, right? So those values, just you need to take that. You see that right hand side, you know 106, right? So we need to, blue values just replace with this and then find out the determinant. Here you can find out, how to find out, same method only. Now 0 is there, you can use that one directly. That also you can possible. 1 into 6 into 6 36 minus minus of minus plus, right? So 36 minus 9 25 plus 6. We are taking 6. 3 into 3, 6. Okay, sorry, 1 into 3, 3. Minus of minus plus. 6 into 2, 12. 12 plus 3, 15. 15 into 6, 90. Okay, 90 plus, how much first one? 25. Right, 90 plus 36 minus 9. 36 minus 9, right? 25. So that is a 117. 27. So either you can take any one, either you can take this way or this way, because once it is 0 means we'll get only two calculations here. Okay, 1 into directly if you want to go for that. So simply if you want just pen, just take one note. Okay, so simply you take this one into 36 minus 9, 27, so plus 90. Same only we will get here. Similar way, use the, just replace for finding delta 2, what you have to take here, this red values, right? So these values should replace by this 106 in center, and then find out again similar way of delta 2. That is the next step we'll see here. Okay, so that is delta 2. I will find out, again replace with those values and then find out the, we got here delta 2. Okay, and the third one again same, only thing is what we have to take that green values. Now we can say those values only for your identification. I am taking green, blue and all, otherwise nothing, only you need to replace the third column. Third column for the I3, for finding I3. So replace with 106. That is only here we are seeing. You see that? Okay. Which one you want, whether it is finding for I1, first column you need to replace. If it is second one, I2, you need to replace second. If it is a third one, we need to replace with third column. Right? Again find the delta 3. Now you got delta 1, delta 2, delta 3 and delta. After finding these values, then it is easy. Simply just substitute these values. Delta 1 by delta is nothing but I1. Delta 2 by delta is equal to I2. Delta 3 by delta is equal to I3. Okay, that is the next step here for finding the currents I1, I2 and I3. You see here, these are the expressions. I1, sorry, this one it is delta only, it is not delta 1, it is a delta. Okay, sorry, by mistake it came. So delta 1 by delta, just see here, this is delta 1 by delta I1, delta 2 by delta I2 and delta 3, because already we found those values. Substitute here, we'll get all three values. So I1, I2 and I3. In this way, we have to find the currents by using Cramer's rule. Okay, so thank you for listening.